Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Stat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
How many of you have heard about will ordering principle? So what does will ordering principle actually tells you in short is that if you take any subset of the natural number or the integer, then you are always going to find a minimum number. Okay, so that's the will ordering principle. So you can actually start with the minimum number and then you can actually go on. Okay, so from the very beginning, you have been introduced to this notion, but the problem was there was not a limiting condition involved. So suppose if I actually told you that what is the least upper bound of the sequence 1 by n. So let me call it as a set for now. Okay. So what is the least upper bound of this? That means what is that number, or does that number even exist, which is the smallest of all the upper bounds that this set is going to have. So now we are actually going to see what are upper bounds, what are lower bounds, and all this, and what is the greatest lower bound of this set. Now, what do we mean by bound? So now let S be a non-empty subset. So let S be non-empty and S be a subset of R. Okay. Then we say that the set S is bounded above if for any given S, any given small s in S, there exists a R belongs to R such that S is less than R. Okay. Now we can actually make it a little bit strong, this statement. So S is bounded above if for any S in R, there is a R, not given. Now for any S in R, for any S small s in S, there exists an R in the real line such that that is always strictly greater than S. So what am I actually saying is something like this, that if I take this set, so now let's take this set S, that is 1 by n such that n belongs to n. So can you give me an upper bound of this subset of real line? 1. Because, so let's call it less than or equals to. Fine. So it should be less than or equals to, it was my mistake. So because if you pick any number or any element from this set, that is always less than or equals to 1. Because this set is 1 half, 1 by 3, and it goes on like this. Okay. So this is what we call as bounded above. Now, similarly, I think you can all assume what is the definition of bounded below. So I'm not going to write it. So bounded below has the same definition. Not same, the similar definition. So now if I take this set, can you give me a lower bound? So 1 was an upper bound because it is actually, so if I pick any element from this set S, they are always going to be less than or equals to 1. So now can you give me an element in R such that if I take any elements now from S, they will always be greater than or equals to that element. Yeah, 0. Okay.
To book a trial class for your preparation courses of IITGM MS, ISIM STAT, and CMIMS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.